Welcome to 3D Online Tuition. It is a three-dimensional e-learning method based on audio, visual, and event.
Yippee! Yay!
Chapter 3. Fractions. 3.1. Fractions. 3.2. Equivalent fractions. 3.3. Mixed numbers. 3.4. Proper fractions and improper fractions. 3.5. Additional and subtraction of fractions. 3.6. Multiplication and division of fractions. 3.7. Combines operations. 3.1. Fractions. Understanding fraction. 1. When a unit of whole quantity is divided into few equal parts, we call these equal parts fraction of the whole unit.
Example 1. When one big unit is divided into 4 smaller and equal unit. This small unit is called 1/4 of the big unit.
Example 2. When one big unit is divided into 9 smaller and equal unit. This small unit is called 1/9 of the big unit. When 2 small unit of 1/9 added, it will become 2 larger unit, or 2/9. Writing fractions. 1. Fraction are written in the form of a over b, where a is called the numerator and b is denominator.
Example 3. In this diagram, the red portion is 1/6 of the big unit. Example 4. In this diagram, the 3 red portion is 3/6 of the big unit. Or, after simplified to the lower term, would be 1/2, or half of the big unit. Example 5. Fractions also can be used to name a portion of a set of objects, or group. In this diagram, the 8 cubes, 3 cubes of this set of cubes, is called 3/8.
3.2. Equivalent fractions. Finding equivalent fraction. 1. Equivalent fractions are fractions that represent the similar value, although they were written in a different numerator and denominator.
Example 6. 2/4 is equivalent to 4/8 is equivalent to 1/2, or half.
Compare the values of 2 or more fractions. 1. To determine which fractions are bigger, smaller or equivalent, we upscale or downscale the common denominator, and later compare the numerators.
Example 7. Which is bigger? 3/7, or 11/21? Answer. Upscale 3/7 to 9/21, and then compare. We will find out that 11/21 is bigger than 9/21, or 3/7. Example 8. Which is bigger? 3/4, or 2/3? 3/4 can be upscaled to 9/12. 2/3 can be upscaled to 8/12. After compare, we can find out that 3/4 is bigger than 2 or 3.
3.3. Mixed numbers. Writing and representing mixed numbers. 1. A mixed number consists of a whole number, and a fraction.
Example 9. 1 plus 3/4 equals 1/3/4, or 7/4. Example 10. 1 plus 1 plus 5/8 equals 2/5/8, or 21/8. Example 11. 1 plus 1 plus 5/8 equals. Expand 1 into 8/8 for similar denominator, to enable addition. The sum result is 21/8, or 2/5/8.
3.4. Proper fractions and improper fractions. Recognizing proper fractions and improper fractions. 1. Proper fractions are fractions in which the numerator, top, is smaller than denominator, bottom.
Example 12. Some of the proper fractions are 3 over 7, 11 over 21, 113 over 117, etc. All proper fractions are smaller than 1.
2. Improper fractions are fractions in which the numerator, top, is bigger or equals denominator, bottom.
Example 13. Some of the improper fractions are 6 over 6, 31 over 21, 119 over 117, etc. All the improper fractions are bigger, or equals to 1.
Changing mixed numbers into improper fractions.
Formula 1. A. B over C can be written as A time C plus B divided by C. Example 2, 5 over 8 is equals to 21 over 8.
Changing improper fractions into mixed numbers.
Formula 2. 17 over 8 is equivalent to 17 divided by 8, which is 2. 1 over 8.
.5. Addition and subtraction of fractions. Addition of fractions. 1. The addition of fractions is the process of finding the sum of two or more fractions.
Example 14. 6 over 21 plus 11 over 21 equals 6 plus 11 over 21 equals 17 over 21. Example 15. 5 over 18 plus 4 over 9 equals 5 over 18 plus upscale 4 over 9 to 8 over 18. After that, we can add the numerator, 5 plus 8. And the final result is equals 13 over 18. Example 16. 1 over 5 plus 3 over 4 equals upscale both 1 over 5 and 3 over 4. After that, we can add the fractions with same denominators. 4 plus 5 over 20 equals 19 over 20. Example 17. 6 plus 15 over 31 equals 6, 15 over 31. Example 18. 5, 3 over 4 plus 5 over 12 equals 5 plus 3 over 4 plus 5 over 12 equals 5 plus upscale of 3 over 4 to 9 over 12 plus 5 over 12 equals 5 plus 9 plus 5 over 12 equals 5 plus downscale of 14 over 12 to 7 over 6 equals 5 plus 7 over 6 equals 5 plus 1 over 6 equals 6 over 6. Example 19. 6 over 5 plus 3 over 4 equals 6 plus 3 plus 1 over 5 plus 3 over 4 equals 9 plus 19 over 20 equals 19 over 20.
Subtraction of fractions. 1. The subtraction of fractions is the process of finding the different of two or more fractions.
Example 20. 7 over 16 minus 3 over 16 equals 7 minus 3 over 16 equals 4 over 16. It can be downscale further to 1 over 4. Example 21. 15 over 18, minus 4 over 9. Equals 15 over 18, minus, upscale 4 over 9 to 8 over 18. Equals 15, minus 8 over 18. Equals 7 over 18. Example 22. 2 over 3, minus 1 over 4. Equals upscale 2 over 3 to 8 over 12, minus, upscale 1 over 4 to 3 over 12. Equals 8 over 12, minus 3 over 12. Equals 8 minus 3 over 12. Equals 5 over 12. Example 23. 6 minus 1 over 4. Equals. Expand 6 to 5 plus 1, minus 1 over 4. Equals. Make 1 become 4 over 4, so that it can able to subtracting 1 over 4. Equals. 5 plus 4 minus 1 over 4. Equals. 5 plus 3 over 4. Equals. Example 24. 5, 3 over 4. 3 over 4, minus 5 over 12. Equals. 5 plus 3 over 4, minus 5 over 12. Equals. 5 plus, upscale 3 over 4, to 9 over 12, minus 5 over 12. Equals. 5 plus 9 minus 5 over 12. Equals. 5 plus 4 over 12. 4 over 12 can be downscale to 1 over 3. Equals. 5 plus 1 over 3. Equals. 5, 1 over 3. Example 25. 8, 2 over 3, minus 7, 1 over 4. Equals. 8 minus 7, plus 2 over 3, minus 1 over 4. Equals. 1, plus 5 over 12. Equals. 1, 5 over 12.
3.6. Multiplication and division of fractions. Multiplication of fractions. 1. A multiplication of a whole number by a fraction or mixed number, is the repeated addition of the fraction, or the mixed numbers.
Example 26. Example 27. Example 28. Example 29. Example 30. Example 31.
Division of fractions. 1. A fraction is a division of the numerator by the denominator. Fraction equals numerator over denominator.
Formula 3. A over B. Divide by C over D. Equals A over B. Time D over C. Example 32. Example 33. Example 34. Example 35.
Three point 7. Combined operations.
Example 36. Example 37. Example 38. Example 39.
Happy learning